Let's take a look at the masses of subatomic particles. So the mass or weight of a proton is equal to the mass of a neutron. So they weigh exactly the same. And then the mass of an electron is about 1/2000th of the mass of a proton or a neutron. So the mass or the weight of an electron is really pretty much nothing. So we're not going to really count the mass or the weight of an electron. So we're just going to be concerned with the mass or weight of protons and neutrons when we calculate our mass number for our atoms. Okay, so another thing we need to look at is our atomic number. And the atomic number is equal to the number of protons. And for each element, they're going to have their own unique atomic number. And each element has their own unique number of protons. Okay, and we'll be looking at that as we go. And then the mass number, how much the atom weighs, is going to be equal to the number of protons plus the number of neutrons. Okay, so definitely would know those two things. Okay, those are pretty important to know. Okay, so atomic number is just the number of protons, and each element will have their own individual atomic number because each element has their own unique number of protons. And then the mass number, how much the atom weighs, is just the number of protons plus the number of neutrons. Okay, so let's just look at some examples. So here we've got a helium atom, and let's look at the atomic number of helium. So remember, the atomic number is just equal to the number of protons. So if we look in the nucleus, we can see that there are 2 protons. So the atomic number of helium is 2 because there's 2 protons. Okay, so the atomic number is equal to the number of protons. So we have 2 protons, so the atomic number is 2. And then if we want to know the number of electrons, remember that the number of electrons is equal to the number of protons, as long as you don't have an ion or some other charged atom. And this one we don't have a charge, so the number of protons should equal the number of electrons. And if we have 2 protons, we should have 2 electrons, which we do. So we have 2 electrons. Okay, and then our mass number for helium, how much does our atom of helium weigh? Remember, that's just going to be the number of protons plus the number of neutrons. So we know that we've got 2 protons, and then if we look at our nucleus, we've also got 2 neutrons. So our mass number would be 4, and that would be our answer. Okay, and let's do another example. Here we've got hydrogen. Okay, so the atomic number of hydrogen, remember the atomic number is just equal to the number of protons. And if we look at our hydrogen atom, we just have 1 proton. So the atomic number of hydrogen is 1. Okay, indicating it has 1 proton. And then remember, the number of electrons is equal to the number of protons, as long as we don't have an ion or another charged atom of some sort. And here we've got 1 proton, so we should have 1 electron, which we do. Okay, and then our mass number for hydrogen, remember, is equal to the number of protons plus neutrons. So if we have one proton, and if we look inside of our nucleus, there's actually no neutrons. So there's 0 neutrons. So our mass number, how much this hydrogen atom weighs, is 1. Okay. Okay, so on the periodic table that we've been looking at, here's our chemical symbol. So we've got a C for carbon. And then up here on the top, they've listed the atomic number. Remember, that's just the number of protons. So carbon has 6 protons. And then down here on the bottom, they've got the mass number. And I know here they've listed as the atomic weight, but we're going to call it the mass number. Okay, remember the mass number is just the number of protons and the number of neutrons. So we've got a mass number of 12. So if we know that our atomic number is 6, and that's our number of protons, and then our mass number is 12, and that's the number of protons plus the number of neutrons, then the number of neutrons, because we know we've got 6 protons, and that means to get to 12 for our mass number, we would have to have 6 neutrons. Okay. The other way that this can be written is actually flipped from what you have written in your periodic table. And so you will also see this on the test where we actually put the mass number on top and then the atomic number on the bottom. Okay, and the mass number is almost always going to be bigger than the atomic number. So that's another way to tell them apart. Because remember, the mass number is the number of protons and neutrons added together, whereas the atomic number is only the number of protons. So almost always your mass number is going to be bigger than your atomic number. So that's another way to tell these two numbers apart. Okay, so this is for sodium. And the symbol for sodium is Na, which is just from the Latin for sodium, which is natrium, which is, they just used Na instead of the English sodium. So, okay, and then just the last topic to cover here would be isotopes. That prefix iso means the same, okay? And isotopes are just going to be atoms of the same element, and they're just going to differ in the number of neutrons they have. So for example, we've got some isotopes of carbon. And here we've written them with the mass number on top and then the atomic number here on the bottom. And you can see the atomic number is the same for each of these. Okay, so atomic number, remember, is the number of protons, so they each have 6 protons. But you can see the mass number is different for each of these. So we have a mass number of 12, 13, and 14. So what they're going to be differing in is the number of neutrons that each have. So they each have 6 protons, but carbon 12 here would have 6 neutrons, because if you do 12 minus 6, that would give you 6 neutrons. And then this one, 13 minus 6, this would give you 7 neutrons. And then this one, 14 minus 6, this would give you 8 neutrons. Okay, so these are all going to be the same element. They're all going to be carbon. And they all have the same properties of carbon because they all have 6 protons, because it's the 6 protons that makes them all carbon. And so they do all have the same chemical properties. So our bodies, if we needed carbon, we could use either carbon 12, carbon 13, or carbon 14 and use that to make whatever we need with the carbon in our bodies. So we could use any of these. Okay, so those are our isotopes. A picture. of the different carbon isotopes. We've got carbon 12 over on the left and carbon 14 over here on the right. And you can see the only difference between them would be the number of neutrons. So carbon 12 has 6 neutrons. So the neutrons are in white. So you can see 6 neutrons. And we've got the 6 protons in purple. And then over here on the right, we've got the 6 protons, but we've got a different number of neutrons. We've got 8 of these white neutrons instead. And each one has the same number of electrons. They each have 6 electrons out here in their electron shells. Okay, and each one acts the same as carbon. They each have the same chemical properties. It's just they're different in the number of neutrons they have.